Hello everyone. So in this video, we will learn about how to do visualization in Python or how to do a data visualization in Python. So as we know that visualization is very important when it comes to data analytics, because visualization really help us out or help in unlocking some of the very important insights which can bring a lot of business value. And as a human we tend to prefer to have more visuals which is easy to understand as compared to when we have a spreadsheet which has million of records, or any kind of a database when we have million of records. It's very difficult as a human to understand what would be the important insights it would be there. But that's the power of visualization. So visualization can really help us out in understanding the nature of the data, as well as to bring out some important information or some of the important trends or the patterns or the insights. So now let's get started and see how can we do data visualization in Python. So in order to do a data visualization in Python, we need to import some of the packages. So starting with, I am just using the package NumPy and Pandas because there will be few data storage and manipulations we will be doing using the NumPys and the Pandas. Then the next two packages what I'm using is matplotlib and the Seaborn. These are the packages we basically use for the data visualization. So in order to do a data visualization in Python, the packages what we need is matplotlib and Seaborn. But 90% of the graphs what I will going to explain to you would be based on Seaborn package. So Seaborn package has made the life of a Python developer very easy, because now with the Seaborn package we can create or design any graph with just one line of a command or maybe two lines of a command, as compared to in some other packages that takes a lot of it can take a lot of steps to create any kind of a graph. The next one is matplotlib inline, which is basically tell Python to display the graphs. And then another thing what I'm doing is to changing the value of the float format values, because sometimes what happens when you have a huge value like in millions or billions, so what Python will do in its graph, that it will show you the value in terms of exponential, like e raised to power 8 or 3.2 e raised to power 10. So that becomes very confusing, like what exactly does it mean. So in order to avoid this kind of a scenario, and we want like an actual number which might say that $1.2 million, which is easy to understand. So for that I am just creating this command pd.setOption display.float format. Now the data set what we are using to showcase the examples of data visualization. So I'm picking up the data what we have used previously for Pandas and then NumPy, which is train.csv, and I've already loaded this data, so we can see the preview or the snapshot of the data. So as you can see, it's a similar data where we have a daily level data which is telling us that every day how many number of sales have been happened and what was the temperature, whether it was a working day or a holiday or what kind of a season it was. And at the same time, this data have been aggregated at the hourly level, not even at the day level but at the hourly level. So at every hour we know what was the temperature and how many sales have been happened. So the total number of sales we can find out through count column. So count is a column which is telling us how many total number of sales have happened on that particular hour of the day. And if you break down this count column, you can get how many were the registered users or the registered sales, and how many were the casual sales or the casual users. So we can see in the first row, on the 1st of January at 12, we had 16 sales, out of which 13 were registered user sales, the user which were registered to a company. So the 13 sales have happened from them, and the other was 3, which would be like a one time or maybe like a free trial or a casual users. So what I'm doing here is that I'm renaming this column from the last column, which is count, to sales, because we will be using some of the functions count. So I don't want to confuse you whether this count is a column name count or it's actually a count function. So what I'm doing is that I'm renaming this count column to sales. And as we know that in Pandas, the way we can do is to use a rename function, df.rename. df is where we have stored our CSV data. .rename is one of the functions which is available in the Pandas. Then I am renaming from count colon to sales. And that, as you know, that x is equal to 1, basically telling us Python to do some operations on columns, and then in place equal to true, the new changes should get embedded back into df. So when I run it, we can see that the name of the column has been changed to sales. And the next is df.describe. So when we describe, we can see some of the statistical thing, count, mean, standard deviation, 25%, 50%. Now this analysis is good to get some kind of a understanding, but they are not very detailed analysis. For example, if I want to know which are my top 5 sales, or which are my top profitable regions, or which are my top profitable days of the months, and so on. So in order to understand or unlock those answers, it's important the visualization. So it's important to create some graphs, some visualization that can answer some of our questions. So let's start with our first graph, which is histogram plot or a hist plot in Python. So histograms are type of a bar plot, which is specifically meant for numerical columns, which basically divide the data into different bins or different intervals. So what I mean is that, for example, somebody wants to know that how many observations in my data lies between from 0 to 200, or from 200 to 400, or 400 to 600. So it's like a frequency or a count of observations in a given interval. So let's understand through an example. So in Python, we can use one of the functions called histplot. So histplot is one of the functions to create the histogram. But before that, let's understand what I'm doing on top. So in this first command, I'm telling what should be the size of my graph. So I'm giving 15 comma size. So then I'm giving the title. So title, I'm giving histogram sales. You can give any name. And this PLT is the name of the package, matplotlib package. So I've given the short name as PLT. And C for Seaborn, I'm giving the short name as SNS. So whenever you see PLT or SNS, it means I'm referring to those visualization packages. And then this xlim is one of the functions in PLT package, which basically tell me what should be the range on the x-axis. So I'm setting the value of my axis from 0 to 1000. Similarly, I'm doing for ylim or y-axis from 0 to 2500. Then I'm labeling my axis. So x label or x-axis name would be sales and y-axis name would be count. And then I am doing all those operations. So histplot is one of the functions which is available in SNS package or Seaborn to create histogram. On x-axis, I'm plotting the sales value. Then data is equal to df means that df is the data where we have stored our CSV file. KDE is equal to true means I want to see the curve as well along with those bins. And the color of the graph would be on. So let me run it. And when I run it, I can see this graph. So the KDE equal to true means this is the curve which I'm talking about. And now let's understand, it's saying that, and these are my ranges. So I can see that these are my the ranges. So the first bin would be starting from 0 would be to maybe 25. So I can see whenever I have a sales from 0 to 25, this happened like around 2000 times. So it means since I have a data of 10,000 observations, so it means 2000 observations have sales between 0 to 25. So I can say that from this graph, hey, 20% of my sales are happening between the range of 0 to 25. Then similarly, I can say that, hey, from 25 to 50, I see around 800 observations. 800 observations. Similarly, I can say that, hey, from 25 to 75 sales, I can see that 700 observations have been happened. So in this way, I can understand, majority of my observations or sales are happening in which interval of values. And on this graph, I can see it looks like a right to it. It means that most of my sales are happening in earlier intervals. So it means most of my sales volumes are happening in my lower ranges between 0 to 25 or 25 to 50, as compared to when I go towards the right, my bins are getting smaller and smaller and smaller. So this means this looks like a right skew graph. It's not like a normal distribution or a bell curve. It's more like a right skew. So in this way, I can understand how the sales distributions are happening across different bins. Now now in this graph we can see that there are a lot of bins are there, around I guess maybe 40 to 50 bins. Sometimes it gets very overwhelming. So let's say if I want to reduce this number of bins, instead of having 50 bins, let's say I can provide my number. So what we can do, we can add one more parameter in this histplot function, bins equal to 10. So it means I just want a 10 bins. So and that too, since we have given the value from 0 to 1000, so and I need 10 bins, so it means the first bin interval would be 0 to 100, second would be 100 to 200, third would be 200 to 300, and so on. So when I plot it, we can see in this way. So now I can say that, between 0 to 200, I can see almost 5000 observations have happened. So it means half of my data set frequency volume lies between 0 to 200 sales in a day. So on a given day, I expect 50% of my sales to happen between 0 to 200. Then from 200 to 300, I can see around 1700 sales are happening on a given day. So this can be very useful, very powerful to understand, numerical column distribution or a sales distribution. So this is the histogram plot. Now we can go to another level of numeric column analysis using box plot. Now box plot is very useful and very helpful in telling me what is my minimum value, what is the 25 percentile, what is 50 percentile, what is the median, what is the max value, is there any kind of outliers in my data or not. So we can use the box plot function. So in SNS we have a box plot function. So on the x-axis I want to plot the sales, and data I'm providing df. So when I plot, I can see this graph, which basically tells me that hey, this one is a minimum value, this particular line. This basically tell me that 25 percentile. So it means that 25% of my sales are happening less than maybe 15 something. Then this particular middle line is called the median value. So median line or a median value. So median value seems to be around 170. This is the 75 percentile. So it means 75% of my sales are happening probably less than 220 or 230. And these dotted lines are interesting, which are like outliers, which is not like a normal trend in our data set. So it basically telling us that, hey, we should deep dive into our data set to understand why these particular outliers are happening, because box plot is expecting that these outliers are not a part of daily trend or daily expectation sales. So this particular sales, which is probably greater than 600, is some kind of outliers which we need to understand. Maybe this huge number is happening just for particular day. There could be some kind of probably a public transport strike, and so this could be a good practice to understand why this particular outliers are happening in my data. This is not what a box plot are expecting, because it's saying that hey, this is out of trend pattern. So maybe it's time to deep dive into your analysis in your data to understand why this particular outliers are happening. What we have concluded about the sales column based on our histogram and the box plot, we can see that sales distribution is right skewed. We can see the right skewedness, and we can see in the box plot there are outliers in our data set. Most of my sales are happening between 0 to 200, or maybe from 200 to 400, but then it's going down afterwards. We can see that most of my sales are happening on a given day is between 0 to 200, but then afterwards it starts declining. And then the median sale is somewhere around 150 to 170. Then now let's do the similar kind of analysis on the temperature column or the temp column. So let's plot a histogram plot for the temp. And this looks very interesting. It's not look like a right skewed or a left skewed. It's more like a distribution or a normal distribution which we expect. But again, it's not like a very perfect normal distribution, but again very close to a normal distribution. And the interesting part about this KDE curve, if you see this curve, it happens that in this curve there are 2 or 3 different type of distributions. Maybe the first curve we can see, which is starting maybe around 8 degrees Celsius, and it's going till 20 degrees Celsius. That could be one distribution. and then another could be which is starting from 20 degree and probably going till 35%. So what it is saying that we have a two different type of a temperature distributions. It means there is two different type of sales are happening across two different kind of temperature distribution. So that is very valuable information, that we have seen a different kind of a trend or a pattern across two different temperature ranges. And then when I plot the box plot, so we can see the median temperature is 20 degrees Celsius. So it means that most of my 50% of the time, people are coming around the median temperature of 20 degrees Celsius. And the max temperature would be around 40 degrees. So this is telling me the max temperature, which is 40 degrees Celsius. Minimum temperature is around 1 to 2 degrees Celsius, and so on. I think what we can do on the box plot is that we can create the box plot across dimension as well. For example, here what I'm doing, I'm adding a season. So I want to see a box plot distribution of sales across different seasons. So as you know that we have 4 seasons in our data set, I want to see across each season what is the sales distribution. So on the x-axis I'm putting season, on the y-axis I'm putting sales, and then I'm passing data equal to df. So now I have created 4 box plot across 4 different seasons. So I can see season 1 has the lowest number of sales. Probably it could be some like a winter season when the temperature is very low, maybe around 1 degree to 5 degrees Celsius. Season 2 and the season 3 are those seasons where the temperature probably get more median level temperature, which is around 20 degrees Celsius, and that's where we can see a similar kind of a pattern, median value very close to each other. And then season 4 has shown a little decline or a dip. Probably it could be a very high summer season, maybe late 30s or maybe high 40s degrees Celsius. So that's why we see a little decline. But I think this is how box plot can tell us, about the sales distribution across different seasons. Now let's understand the next graph, which is correlation. Now correlation is very useful when we want to understand the relationship between one variable against other variables. So for example, here I see the sales column. So is there any kind of a relationship between, let's say, sales and the temperature? Can I say that, can the data tell me that is there any kind of a relationship between temperature and sales? What I mean is that, does it happening like when the temperature is increasing, my sales are also increasing, or if the humidity is increasing, my sales are decreasing? So do we have this kind of a relationship? And correlation is one of the feature or heat map is one of the feature in the Seaborn package, which can unlock this kind of answers. So df dot core function will basically find the correlation between each variables. The output of it I'm storing in this particular variable. Then we can use a heat map function in the Seaborn package. I'm passing this variable, and annotation is equal to true so that I can see the value of their relationship. And so easy way to understand, let's say sales. Let me pick the sales because I am very much interested in know, is there any kind of a relationship between sales and some other dimension. So let's say sales and season. So sales and season is showing 0.16. So what it's showing is that when there is a positive relationship, so the value should lie between 0 to 1. And if there is a negative relationship, then the value will lie between 0 to -1. So as we go closer towards 1 or -1, it shows that the relationship is getting stronger and stronger. So for example, here the value is only 0.16, which shows that there is a positive relationship, but it's not that very strong. It means our sales has a positive relationship on a season, but it's not a very strong conclusive relationship where we can tell that, hey, seasons play a major role in your sales. Although it's showing that there is a small relationship, but it's not a very powerful relationship. But when we can see that sales and the temp has a positive correlation of 0.39. Again, it's not a very strong relationship like 0.9 or 0.8 or something, but it's showing that there is a relationship which we need to look into it, which means that whenever temperature is increasing, we have seen some increase in the sales as well. So what we have learned or observed is that sales and the temp has a positive relationship of 0.39. So sales have shown increase with increase in the temperature, although it's not very strong, but it has some kind of a relationship of 0.39. Let's look out for another relationship between sales and humidity, which is minus 0.32. So since it's a negative value, it means there is an inverse relationship between sales and humidity. What does it mean is that when humidity is increasing, my sales are decreasing, or when my humidity is decreasing, my sales are increasing. So there is some kind of a negative relationship or an inverse relationship. So I can say that 0.32. Again, it's not a very strong relationship, which is supposed to be close to 1. But there is a relationship which is saying that whenever humidity is increasing, my sales are decreasing. Now, pair plot is another chart which we can use, which in my opinion is kind of a two-way chart. So we can see two different kind of a chart. One, heat map, what we have seen here, and another is like a distribution chart. So what I'm doing is that I'm using the pair plot, and then I'm passing two variables, temp and sales, because I want to see the relationship between temp and sales, and data is equal to df, and I'm adding one more parameter, hue equal to holiday. So holiday. So I want to see, is there any kind of a relationship when holiday equal to 0 or when holiday equal to 1. So when I run it, so black dots are all holiday values when there was a holiday, and light pinkish one when there was no holiday or a working day. So what it happened that on a diagonal axis, so diagonal axis is this one. So these are the diagonal axis. So on the diagonal axis, you will see the distribution or a histogram kind of a distribution for that variable temp. So this is a histogram distribution of a temp. But on non-diagonal axis, which is this one, although it's also a diagonal, but for this simplicity, I'm considering this as a non-diagonal. So on the non-diagonal, it shows a heat map kind of a relationship between temp and the sales. So I can see that temp and sales has shown some kind of a positive relationship, but again, it's not very strong like 0.8 or 0.9, but it's showing some kind of a relationship. And similarly, I can see for sales and temp. And similarly, when the temperature is increasing, sales are increasing, but again, it's not very strong, because I can see with increase in temperature to around 35 degrees, my sales are going down. But again, it's showing some kind of a relationship. So the pair plot is very interesting, because in one pair plot, you can see two different kind of a graph. One is a histogram kind of a distribution on the diagonal axis, and on the non-diagonal axis, we can see heat map kind of a relationship or a correlation kind of a graph. The next is a pie chart. Pie chart is like a circular graph where we can divide our dimensions, which can tell us what is the numerical proportion of each of them. So let me plot it and I can explain you. So let's say I want to understand, since we have 4 seasons, I want to see that on each season how many total volume of sales are happened and what was the percentage distribution of each of them. So for example, maybe I see that season 1 has a 20% of the sales, season 2 has like 30% of the sales, season 3 has 45% of the sales, and so on. So now in order to do that, first I'm setting the color palette, so I'm taking as a bright color. Then I'm doing a group by, so that for each season I can get the aggregated sales volume. So since we have already learned about the group by function, so I'm skipping this up. So we can see that on the dimension I'm passing the season, then on the numeric I'm passing the sales, and I am aggregated based on the sum. Now the next thing I'm doing, I'm using the matplotlib package plt and using its function called pi. Then what I'm doing is that I'm passing the df underscore season sales, and on the labels I'm passing the dimension, which is season, and the colors is equal to palette color, and this auto pct basically will print the percentage values. So when I run it, it will create the pie chart. So this 1, 2, 3, 4 represent the seasons, and this value is the sales distribution. So I can see that season 1 has the least 15%, whereas season 3 has a highest volume distribution or a sales volume distribution, which is 30%. So it means that 31% of our sales are coming in season 3, whereas season 2 it's coming 28% of the total sales. Another interesting thing what we can do in this pie chart is to do explode thing. So basically it will highlight my top percentage slice. So explode equal to explode. So I'm telling in explode, hey, there are four slices are there, and make my first slice as 0.1 because 0.1 the first slice has a highest distribution. And we can see that the slice which has a highest distribution, it has separated out. So I can easily see that, hey, my season 3 is the highest, 31% sales. So it means out of the total sales, 31% of the sales are coming in season 3. So now let's learn about the bar plot. So bar plot is kind of similar to like a histogram. In histogram, we find the frequency count for numeric columns, but for the bar plot, we find the frequency count for non-numeric columns. So let's say we have a holiday column. Holiday has two values, 0 and 1. So I want to understand, how many observations are falling when holiday equal to 0 and when holiday equal to 1. So the way we can do, there are two ways we can do. I mean, there can be multiple ways, but in this example, I'm showcasing you two ways. So we have already used multiple times this function value underscore counts. So what it will tell me that df holiday value count. So let me break down this one. So when I run this command, it will tell me that for 0 and 1, how many total observations are there. So it shows me that for when holiday equal to 0, I have around 10,500 observations. When holiday equal to 1, I have around 311 observations. But if I want to see into a bar plot, I can include this function dot plot kind equal to bar, because we are plotting a bar plot. And now we can see in the graph, for when holiday equal to 0, we have around more than 10,000 observations, and for 1 we have around 300 observations. Now similar kind of a graph we can plot using a Seaborn package. So it has a function called count plot. You pass a dimension, let's say x equal to holiday, and it will show you how many total number of observations are there when holiday equal to 0 and when holiday equal to 1. We can do the same thing with season as well. We can see across season as well. We see that across each season we have almost same number of observations. Now, so in this example, we see how many total observations are there in each of the season. Let's say a next level that I want to know that how many sales volume are happened across each season. So these are total observations. So I can see that in each season we have almost same number of observations. Now we want to see what is the sales volume across each season. So what we can do, first we need to do the aggregation at season level. So I'm passing the season, the numeric column is sales, and then I'm aggregating based on the summation. So it will basically tell me that, hey, across 4 seasons, this is my total volume of sales. Now, in order to see on the bar graph, we can use the function sns.barplot. X equal to season because we want to plot the dimension on the x-axis. Y-axis we are plotting the sales, and then on the data I'm passing the value df underscore season, which is we have calculated here. And now we can see on the bar plot that, hey, season 3 has a highest sales volume and the least is the season 1. Now let's create a scatter plot. Now scatter plot also shows a relationship between two numeric variables. So it's kind of a correlation or a heat map what we did it earlier, but scatter plot will create a relationship between two numeric columns. So let's say I want to understand between temperature and sales. So I'm plotting on x-axis the temperature, on y-axis the sales, and we can see the scatter plot. As we already know that the relationship is not very strong, but there is some positive relationship between sales and the temperature. So in this way we can create a scatter plot to show the relationship between two numeric variables. What we are learning is LM plot or a linear regression plot. It goes one level up of scatter plot. So let me show you with one example. Let me remove this particular parameter. We can do it later on. So the function is LM plot, and on the x-axis I'm plotting temperature, on the y-axis I'm plotting sales, and we can see that it looks like similar to like a scatter plot, but what it is done is that it added this line, this linear regression line. I don't know whether it's visible or not, but you can see that there is a line is going. It's showing about the relationship between temp and the sales. So let's say we want to see this relationship across a column called holiday, on a holiday and a non-holiday. So we can add this parameter u, and we can see that the line looks quite similar. This orange line which represent for a holiday, and the blue line for the holiday. In this way we can use some kind of a linear regression as well to understand about the relationship between the variables. So it's basically like a one step up of scatter plot. The next thing what we can do, instead of overlapping those two graphs for holiday equal to 0 and holiday equal to 1, we can segregate those two graphs as well. We can do by adding column. So in the above we were passing the value u, here we can pass the call. So column. So column equal to holiday. So in short is COL. So when I run it, I can see those two graphs for holiday equal to 0 and holiday equal to 1. So in this way also we can segregate the two graphs based on certain column or based on certain values as well. So the next plot what we are learning is a joint plot. So joint plot is a very interesting plot. In one graph you can see two different kind of analysis. One for bivariate analysis and another for univariate analysis. So let me run. So in the SNS package we have function called joint plot. So let's say I'm doing the same thing. On the x-axis I'm plotting the temp, and y-axis I'm plotting the sales. And we can see this one. So sales and the temp, you can see it looks like more like a scatter plot. We can see this relationship, but at the same time, at the end of those graphs, it's also showing a histogram plot as well. So for sales, it's showing here histogram plot, and for the temperature, it's showing the plot here. So this is very helpful that in one graph we can see two different kind of analysis. So now let's see. In the next step, what we do is to add one more parameter, kind equal to hex. Now in this graph, you can see that the dots which are more darkened, blue or black, those are the spots or the points when the intersections are happening between temp and the sales. When we can see that which is our ideal temperature when most of the sales are happening. But again, this graph is not very, at least for this analysis, not very useful or not very conclusive. But let's see some other graph. Let's say I'm adding, instead of doing hex, let's do KDE, and then fill is equal to true. And when I run it, I can see that this part, which is very dark grayish part, I can see that it's saying that when your temperature is somewhere in between this range, that's where some of your sales volumes are coming along. And another side, it's showing this small thing as well, when the temperature is somewhere between this spot, or at the same time also it's showing some of the high sales volume. So this is like an intersection between sales and temp. Is trying to find out which is that intersection where we can see that which is that ideal temperature when maximum sales are happening. And when we add this kind is equal to regression, it can add the regression line as well. So this is another add-on. So this joint plot is very useful graph where you can see both the univariate analysis and at the same time the bivariate analysis. You can see all those intersections are happening, which is our sweetest spot, and it's very useful graph. The next we will learn about the line chart. So there would be a lot of times when we do the analysis on the time series. So we want to understand some seasonality, some trends over the last 12 months. We want to understand which are our profitable months, what kind of is the sales are declining or going up. So line chart would be very helpful in that aspect to understand our seasonal trends or monthly trends or yearly trends. So what I'm doing first is I'm converting this date time column to a date column because our data type is object here. So let me run and showcase to you. So date time data type is object. So let's first convert into a date column. Then next what I'm doing is I'm extracting the month, year and the day from the date time. Let me run this command first. And now as we can see that we have extracted the month, year and day. So first thing what I'm doing is I want to understand that for every month what is our aggregated sales. So for example, in the month of January, what is our total aggregated sales? So for the month of Feb, what is our total aggregated sales? So I'm doing the group by on month and aggregated based on sales. So we can see this month and sales, and then we can use the Seaborn package, which is line plot. So on the x-axis we are plotting the month, on y-axis we are plotting the sales, and on the data I'm providing this df underscore month, which we are just computing. And we can see that our highest sales are occurring across summer season, which is June, July, August, and as the winter season approaches, our sales have started going down. So this is the trend we can see on the line chart. Now, if you don't want to go through this group by or this aggregations, we can use this parameter as well, estimator is equal to sum. So when you use estimator is equal to sum, it's basically it will aggregate the sales across month by using the sum parameter. And CI is equal to none is equal to confidence interval. So we will not show the confidence interval. Now this line plot can be shown through point plot as well. So in the point plot, we can see those point as well. Now this particular line, x rotation is equal to 90. So it has rotate the name or the label of the axis at a 90 degree. So if you don't do that, you will see your rotation or alignment or orientation of label in this way. But if you want to turn around to a 90 degree, you can use this command orientation or rotation is equal to 90. So we can use line plot or a point plot to create our line chart or some kind of time series trend. I personally like the point plot because it can create those points as well, which is easy to see the numbers. And then we can use estimator is equal to sum to aggregate our dimensions based on sum or any kind of aggregations. And the same we are doing for the monthly. Let's do if you want to do for yearly. So I'm using those point plot, and on the x-axis I'm plotting year, y-axis sales, and then I'm aggregating on sum. So when I run it, I can see in 2011 we have this many number of sales, and in 2012 we have this many number of sales. So we can see that in 2012 there is an increase of our sales from 0.8 to 1.3. So let's see if you break down the sales based on working day. So I want to see a trend based on working day. What is my trend? So the way we can do is I'm using the same point plot, x-axis month, y-axis sale, estimator sum, and then adding a new parameter q is equal to working day. Now I can see that so this orange line represents the working day, whereas blue line is a non-working day, and we can clearly see that for every month we have more sales on a working day as compared to a non-working. So people might be using these services during the working day, probably they are commuting to their workplaces. And let's see the same line chart or a time series chart based on season. So based on season, so we can see that this is our season 1, orange one is season 2, green is season 3, and season 4 is red. So we can see that season 2 and season 3 has a it seems like a seasons of spring and the summer, and that's why we are seeing our majority of the sales. And let's see another analysis where we want to see month by month comparison between current year and the previous year. So what I'm doing is that on the x-axis I'm plotting month, y-axis sales, then aggregated estimated equal to sum, and then the hue is equal to year. So that would be our comparison. So we will see that do a month by month comparison between previous year and the current year. And here we can see that there is a big increase in the number of sales in 2012 across each of the months. And the pattern looks quite similar. If you see, the pattern looks quite similar. Then the next plot is a cat plot or a categorical plot. Now the categorical plot itself will give you a lot of different options to create the graph. So whatever we have learned so far, whether it's a bar plot or a scatter plot or any kind of a plot, we can plot through cat plot as well. So for example, let's say I want to create a bar plot. So instead of using the bar plot function, I can use one function cat plot, and then inside I'm passing kind equal to bar. So kind equal to bar basically telling to plot a bar plot. So it will tell me that for every month what is my total number of sales, total volume of sales. Similarly, in the cat plot, I can plot point chart as well. The point chart. So we can create a point chart as well. So this cat plot is one function which is giving you the flexibility to create multiple different type of charts, and just you need to pass the parameter kind. So what kind of a chart you want. So since you want point, I'm creating a point chart, and since I pass the parameter column underscore wrap equal to 5, it has created a 4 different charts here. So let me put it instead of 5. I think let me put 4 because there are only 4 seasons are there. So that's why it's showing only 4 columns. So I can see for each of the column or each of the graph, it telling me the point chart between 0 and 1 and telling me what is my total volume of sales. And similarly, using the cat plot, we can also plot the box plot. It just we need to provide kind equal to box, and it will create the box plot for us. Since we have mentioned that column equal to season and column wrap equal to 4, it has created the 4 different seasons, and each season representing a one particular season. 1, this is for 2, this is for 3, this is for 4. And on a simpler way, we can do it this way as well. In the cat plot, I am passing the kind equal to box. For every season, plot me the total volume of sales distribution. You can see this way. And now the next plot is a strip plot. So strip plot is a graphical data analysis technique for summarizing a univariate data set. Univariate. And these dots can be overlapped. So let me run it. So the function is strip plot. On x-axis I'm plotting season. On y-axis I'm plotting sales and data equal to year. So what is telling me that whenever you see a lot of overlappings are happening or the more concentrations are happening, that is our sweet spot for that particular month. For example, for season 1, the sweet spot or the more concentrated or density areas are between 0 to 200. And for season 2, it's between 0 to somewhere around 400. So that's a more overlapping and more concentration or density is happening. And same with season 3 and 4. But again, I mean, there are some limitation of this strip plot. I prefer to use a swarm plot because of this overlapping. I'm not able to understand, whether higher percentage of the values are lying on when the sales is 0 or when the sales is 10 or 20 or 30 or 40. It's not telling me this thing. And plus, because of the overlapping, it's not very easy to understand. So what we can do is we can use the swarm plot. Same thing, swarm plot. On x-axis I'm plotting season, y-axis I'm plotting sales. and it will take some time. So you have to remember that when your data set is huge, I would not use the swarm plot because it's computationally very expensive. And when your data set is of small to medium size, maybe that's where you can use the swarm plot. Just wait for a few more seconds, and here it comes. And you can see this looks much better and easy to understand. What is telling me is that on season 1 we have a lot of distribution between 0 to 250, but after 250 it starts going down and down and down and down. Similarly with season 2 we have the concentrated region is between 0 to 400, but after 400 that swarm plot is just shrinking and shrinking and shrinking. So it's saying that around 800 it's very small, it's the least. And similarly with season 3 it's telling me the sweet spot of the more density or concentrated region is between 0 to 600, and then afterwards it's shrinking a lot. And same with the season 4. So strip plot and the swarm plot can be used to understand the univariate analysis. We can easily see that what kind of a density region is present on those areas.